So now, coming to this question, see the direct answer. If at all you want to have the direct answer here, we have SA is equal to distance traveled in by A in 8 seconds. So this is SA. SB is the distance traveled by B in 8 seconds. SA, SB. And when you combine SA and SB, that is when you add the lengths SA and SB, you get the length of train B. Okay. And considering the relative velocities of A and G with respect to ground, we have VAG is equal to VA minus VG, and since the observer is in the ground frame, when the velocity of ground is 0, assumed to be 0, so we have VA minus 0 is equal to VA. Similarly, we have velocity of B with respect to ground as equal to B. And from that, we can write that SA is equal to VATA and SB is equal to VB into TB. VA is 25, VB is 15, time is common for both, 8 seconds. Therefore, what we get is 25 into 8 plus 15 into 8, which is 200 plus 120. And therefore, the correct option would be this much is 200 and this is 120. Therefore, length of B will be equal to 200 plus 120, which is 320. Right? Now, see, we did this question using the scalar frame. Right? Now, before we approach the same question with the vector frame, I would request that you spend some time, well, of course, a significant amount of time, to see how did we arrive at this diagram and how did we arrive at this formula for that matter. Okay, now this is going to be a bit lengthy as usual. It is going to be it may take much of your time, and you will have to write along with me to make sure that things makes more sense to you while you do this question on your own. Okay, so let us try to go to the fundamental of this question here. So what we have here is a passenger sitting in a train at 90 km per hour observes another train B moving in the opposite direction. So we have train A and train B. Train A is 90 km per hour and train B is moving at 54 km per hour, and the observer in A observes this train for 8 seconds. So the observer here is basically inside this, the passenger is basically inside this train A. Now what I'll do is, I will try to solve this question. Wait, let me just show you that first. So I'll try to solve this question by considering the observer on the ground, or the person who is actually seeing these two motions of train A and train B with the respective velocities VA and VB with respect to the ground, which is stationary and therefore is a non-inertial frame. So moving not inertial frame, it should be inertial frame, right? So it's either stationary or inertial and moving or non-inertial. So since ground is assumed to be stationary, this frame is an inertial frame. And since we are observing things from the ground, velocity of A becomes velocity of A with respect to ground, and velocity of B becomes velocity of B with respect to ground. Well, it's like this. It's velocity of A with respect to observer, and since the velocity is since the observer is on the ground, that becomes velocity of with respect to ground. It is velocity of B with respect to observer, which is actually velocity of B with respect to the observer being on the ground. It becomes velocity of B with respect to ground. Okay. Now, let us try to revisit this. What is given in the question? A passenger sitting in a train moving at 90 km per hour observes another train B moving in the opposite direction. So these two words are important, at 90 km per hour and opposite direction. So train A is moving at 90 km per hour. Okay. Train B is moving at 54. So if I were to say this, train B So train A is moving towards 90 kilometer per hour and train B is moving in the opposite direction. Okay. Observer is on train A and train B is observed for 8 seconds. Right. Now the immediate question comes up. What frame are these velocities given in? Or in other words, what frame are these velocities measured with? Measured with. Unless explicitly stated otherwise, all the velocities which are given in these problems are with respect to the ground. Okay. So, velocity of A of train A is actually given to be 90 km per hour with respect to the ground. Velocity of train B is 54 km per hour with respect to the ground. Okay. So, or in other words, there might be some questions which would give you ground or earth frame, right? Now, why do we know that? Because the observer is mentioned only in the context of how long the train B was visible. Or in other words, the observation is mentioned only with respect to absolute or time, which is absolute, and not speed, which can vary depending upon where the observer is standing. Okay. Yes, I do understand there might be a bit of lack of clarity there. We'll come to that. So, since there is no mention of relative speed or a phrase which says with respect to train A, the speeds here are simply stated as train A is moving at 90 and train B is moving at 54, which means that this is given with reference to the ground frame. Now, what will be the case if it was not ground frame? Rather, the frame was any other moving frame. In that case, the velocity of train B will be given with respect to train A. And the question correspondingly will say train B is approaching train A with a relative velocity of 54 km per hour or any other associated forms or associated phrases. Okay, right. Now this gives you the significance of reading the question and identifying which frame it is, because almost every chapter from now, let it be laws of motion in a plane, work energy power, every question in the coming topics will primarily depend upon the frame of reference, right? The frame of reference. And if the frame of reference varies, it will definitely result in varying equations, but irrespective of which frame you choose, the final answer has to be correct. Okay, so some frames, some of the terms in one frame would be positive and the same in the corresponding frame of reference would be negative, yet the final answer will be the same. And since this confusion exists, choosing the frame of reference becomes really important. All right. Okay, so now that we understood that this question is based on ground frame and not any other frame, the given measurements are with respect to ground frame. So the next question comes up, how can we solve this question? Do we have to stick to the ground frame or can we do this question in any other non-inertial frame? Now, see, this question can either be solved with ground frame as a reference, ground as a reference of frame, and train A as frame of reference, train B as well. Now I will do this question using ground and train A, and you will try solving this question using train B. All right. So let me just take you one step higher to this, in addition to what's required basically. So this question can be solved in a ground frame in both scalar and vector approach, train A with scalar and vector approach, and so be the case with train B. Okay. So solving the every step of this would be really, that would be way too much of unnecessary utilization of time. Then let us not go into that. But we'll try to do either of these in both scenarios. Okay. So this solution we will stick on to the ground, from the ground, using the scalar method. Okay. So coming one more time to the visualization of the solution, which is the initial step. At time t is equal to 0 and at the corresponding displacement being x equal to 0, the front of train A aligns with the front of train B. I'm sorry, front of train A aligns with the front of train B. Okay. So the observer at time t is equal to 0 and at x equal to 0 sees from his point of view that front of train B aligns with the front of train A. Now see, every time I use this diagram, the explanation and the process of understanding this would become really difficult. So what I've done is I've chosen simpler diagrams which would translate like this. So front of train B, this is front of train B, aligns with train A, front of train A. Okay, maybe I can just mark it like this. Front of train B aligns with front of train A. Velocity of A is 25 meter per second and velocity of B is 15 meter per second. Okay. Now, after some time, some length of train B has passed the observer, which in this case is the ground. Has passed the observer means it has passed this point x equal to 0. Okay, but has not crossed the train A completely. Train A, which earlier was here, has now moved some distance, and since it has moved some distance, we'll call that distance to be SA and the corresponding here as SB. Okay. At t is equal to 8 seconds, according to the given question, observer on train A finds that train B has reached the observer on train A, he finds the rear end of train B. So the observer was standing here, now he sees the rear end. Okay. So here he was observing the front end, whereas here he is now seeing the rear end. Okay. After this, if we try to analyze only at time t is equal to 0, which is the initial position, and t is equal to 8 seconds, which is the corresponding final position, the front of train B aligns with front of train A aligns with B, which is the initial condition, and the observer at A or the front of train A aligns with the rear of train B, which is at C, being the final position. If you are able to visualize these two positions clearly, or maybe what I can do is I can just take out this portion, okay, and if we analyze this final picture at t is equal to 8 seconds, this length here represents displacement of A, which is SA. Well, I think every time I use displacement, it means we're using the vector approach, right? My bad. So yeah, distance. Sorry, my bad. Distance, because we're using only the scalar part here. So distance SA is equal to this much distance would be SA, and similarly, this length here would be equal to SB. Now SA is the distance traveled in 8 seconds and SB is the distance traveled in 8 seconds. So distance traveled by A in 8 seconds and distance traveled by B in 8 seconds. Okay. So this is where we arrived earlier. Now, since every observation is done with respect to the observer, the displacement and the corresponding or speed and the corresponding distance, or displacement and the corresponding velocity, should be expressed in terms of or expressed in reference to the ground. So velocity, okay, now again I think using v is not the correct letter of choice here, since I've not used vector. Since we are using scalar, I should be phrasing this as speed. My bad. So speed of a with respect to ground is speed of a minus speed of ground, which is va minus 0, which is equal to va. Now, since the ground is stationary, both these velocities are the same. And we have SA and SP as the corresponding distance traveled by A and distance traveled by B. I think I have made a minor mistake here. This arrow should be ending here, because the observer was at this position and then he had moved so far like this. Okay. And yes, and later we have the solution, which is by visualizing this part. This is the complete length of train B, which can be inferred as speed distance traveled by A by plus distance traveled by B, which, as we discussed earlier, is speed into time, speed of A into time of A, 25 into 8, 15 into 8, which is equal to 120. Okay, I think I made a couple of wrong references here and there, but yes, that's the whole idea. Okay, I hope you are able to make sense out of this. And like I said, this is done with respect to the scalar method, using ground as the frame of reference. Now let's try to do the same with respect to the vector approach. Okay.